So yesterday we have seen the list of tokens. Token means a smallest unit in the program. Means whatever the symbols or letters or words we are using, each part will be treated as a token. So combining of all these tokens, we'll have the instructions or we'll have the program. Okay. So here in the tokens, we are having keywords, identifiers, constants, strings, special symbols, and operators we are having. If we know all these, then we can know what are the symbols we are using, or what's the meaning of the symbol and a particular word. We can easily understand so that we can easily use them in the program. Okay, let us see one by one. The first one is keywords. We have 32 keywords in our C program. In our C language, we have keywords. Keyword is nothing but a reserved word. So which have a special meaning. So it gives a special meaning to the compiler so that the compiler can understand. So if we give auto, these are the storage classes actually. These break, continue, and all we can see in the control statements. What's the use of the break and continue? Breaking of the statements and continuing of the execution. So we have the double float int short. These are the data type names. So these are the reserved words. These reserved words having the special meaning, and the compiler can understand what does it mean. Okay. So here these reserved words we should not use as variable names or as function names, as array names, some pointers names we are having. So we cannot use, if we use these reserved or keywords, reserved words for the as a variable name or function name, then there will be a problem while execution. Okay. So these are the list of keywords which we are having, nearly 32 keywords in our C program. Next, the second type in the tokens, that is identifiers. Identifiers. Here the identifiers are nothing but the variable names or the function names will comes under the identifier. So here we can call them as user defined names. User defined means we are giving the names, the variable names. Here, observe here, we are having int role underscore and wo. Some name here they have given, that is called a variable name. Sir, what is a variable? Variable is a name given for the address location. So here our data will be stored in the memory. In the memory there will be blocks. For each block there will be an address number. A number will be there. So that address number, whatever the location or block we are having, for that block we are giving a name. That name is called a variable name. So there will be an address number also. Okay. Here percentage, underscore marks, average, these are the variable names. So how the variable names should be, or how the function name should be, how an array name should be, how a pointer variable name should be. So for that we are having some constraints. So the constraints are, observe here, the variable name should be started with an alphabet, and can be and it can be started with underscore also. So the first constraint, a variable name should be started with an alphabet or underscore. An alphabet or underscore. That is first constraint. A variable name should not be started with a digit. For example, here it is right, acceptable only. But if the digits, these digits are starting of the variable, so it that time it won't be acceptable. Okay, so it should not be started with any digit. And moreover, here variable name will not accept any special symbol except underscore. Variable name, it will not accept any special symbol except underscore. This underscore can be at starting or middle at ending. It will be accepted. Okay, this is one constraint. And for the variable name, it is a single name. There should not be any spaces. It is a single name. There should not be any spaces. It is a single name, whether with underscore or a combined name, or a combined name we can write. But there should not be any spaces for the variable name. So these are the constraints for the variables. But here, a variable name should not be a keyword. That's what I told you. This variable name should not be a keyword. Observe here, int, double, float. So previously I have shown you some 32 keywords are there, which gives a special meaning to the compiler. So those keywords, these are the data types purpose we are using these three keywords. So this variable name should not be the reserved word, that is keyword. It is an user defined name. Another name can be given, but we should not give the variable name as keyword. That time that will generate an error. Okay. So identifier means here we are talking about the especially variable name. It's a variable. It is data type. Int is a data type. This is a variable name. A variable name is our choice. See, we have seen what are the constraints to be followed. Okay. So the second type of tokens are identifiers. Next one is constants. Next one is constants. Observe here. So what are the constants we are having? Numeric constant and character constant. So in the numeric constant, we are having integer constant and real constant. Here integer means there will be an integral part only. There is no fractional part in the integer constant. Sir, what is constant here? Constant means a fixed value. We cannot change it. So here 0 is a constant, 1 is a constant, 2 is a constant, 10 is a constant, minus 20 is a constant, minus 30 is a constant. All numbers are, all integral values or numbers are constants only. What does it mean, sir? So 10 is a constant. We cannot change the value 10. This 10, we cannot change it. That's it. It is a constant. We can make use of 10. We can make use of 0. There are no another meanings for those constants. Those are fixed values. 0 is 0. 0 doesn't mean another value. 0 is 0. So all integral values will come under all integral constant. It is a constant. So here the fraction points, if we have the fractional part, that will come under the real constant. All the numbers, either positive or negative, will come under the real constants. Then character constant. We have two types. Single character, a string character. Single character constant will be represented in the single quotes. Then if you represent a value that is within the single quotes, that is called a character constant. Here within the single quotes, I have used 2, I have used a, I have used a symbol. All will becomes under the character constant only if you are represented with the single quotes. Okay. If we represented with the double quotes, that is called a string constant. If you represented it in the single double quotes, that is a string constant, this will be treated as a string. Okay, so these are all some special tokens we are having in our C language. Okay, so simply we are calling these are the constants. Actually, we have one more concept called coding constants. Coding constants, I'll teach you later. There are two types, define constant and memory constant. So two constants are there. While writing the coding, I'll teach you. It is about the coding. Sorry, constants. Next, we are having the special symbols. Special symbols in our language. What are the special symbols? What we call them? You need to remember the symbols. Okay. See the symbols. We know comma. We know dot. Mostly, sometimes while calling, we'll use this dot. That's not in even see another language. Semicolon. You must know the meaning. Semicolon. We know the semicolon. We'll use it for ending of the statement in our C program. Colon. Colon also we'll use whenever required. In ternary operator, we'll use this colon actually. Question mark in ternary operator only we'll use this question mark. Single quote to represent the single character constant, we'll use a single quotes, and a double quotes to represent the string, a string collection of characters. We'll use double quotes. Within the double quotes, we'll represent a string. Exclamation, exclamation. Uh, Actually, mostly it is not needed, but in the string constants we'll use it. And a vertical bar, slash. So here it is backslash. We won't use this much. This backslash is to represent the escaping characters. Escaping character means backslash n. Means we can the control will move to the next line. In such cases we will use that. And tilde symbol we won't use here mostly, but negation purpose, negation, some negation purpose, in the operator symbols we'll use this. Underscore, dollar, underscore in our symbols we are using. Then percentile, it is called a modulus operator. We are going to see that. Next, ampersand, to represent the address we'll use this. Address of a variable. To represent the address of a variable, we'll use this. And caret, cap symbol, we'll use it for exclusive or operation. Asterisk, we'll use it for multiplication purpose. We know the arithmetic operators. And equal, less than, greater than. And here we will call them round brackets as left parenthesis and right parenthesis. We can call them as parenthesis. Parenthesis. So here these are the square bracket symbols. Square bracket symbols. Here it is curly bracket symbols. Curly brackets. Hash. Hash we will use it to hash include, hash define. In such cases we will use. So here the special symbols are here ampersand and these parentheses, hash, dollar. So these are all these are the special symbols we are having. Remaining most of the symbols we'll use them in the operators concept. Okay, so you have to know the words ampersand and the here we can call we will call it as ampersand. Remember ampersand. Then asterisk, star is represented with asterisk. Actually, minus in our Linux environment, we'll call it as if it is an operator, if you are performing an operation, we'll call it as minus only. But while in the Linux environment, options purpose, we'll use it. So that time we'll call it as hyphen, hyphen, hyphen. So tilde symbol in shell scripting also we'll use it. There is another meaning for this. Back tips. Back tips also will use in shell scripts. Okay. So these are the symbols we are having in our C program. Okay. Now the most important concept, that is operators. Operators in C language. What are the operators we are having in our C program? See here, all these are the operator symbols and types we are having. We are having the category. Actually, three categories we are having. Unary operators, binary operators, ternary operators. Unary, binary, ternary operators. Observe here, three kinds we are having. Three kinds of operations we are going to perform. Unary operator required a single operand. You have to know the operand and operator. For example, if I write a plus plus, here plus plus is an operator, a is an operand. Variable name is nothing but an operand. Operator will be having. So if we can if we are able to perform the operation with a single operand, that is called unary operator. So here the unary operator, we are having increment and decrement operators. This is a single type as unary operator. Okay. Next, binary operators means two operands are required. If you want to perform addition of two numbers, a value is 2, b value is 4. A plus b, I am writing a plus b. A is an operand, b is an operand, plus is an operator. Here, two operands are required for the operator. So in such cases, we will go with binary operator. Means two operands required. Up to here, the list of operators, arithmetic operators, relational operators, logical operators, bitwise, special, and assignment operators will comes under the binary operator. These operators required two operands, means two variables required to perform to evaluate an expression. Ternary operators means here three operands are required. Three operands are required. So that is called ternary operator. We can call it as conditional operator. Conditional operator. So it is special operator, semicolon, and dot. So let's see how to perform all these operations and all. See, in increment and decrement operators, plus plus it is single operator, minus minus is a single operator. Okay, to perform increment and decrement. Here we will be having pre-increment, post-increment, pre-decrement, post-decrement. Such operations will perform. Arithmetic operators, here plus minus asterisk division. Here it is called modulo division. This percentile symbol means it's the modulo division. It gives the coefficient value. Sorry, it gives a reminder and it gives the quotient value. Slash means quotient value, here reminder value will be given. So these are the plus plus and minus minus also we will use based on the need. Next, relational operators. Next one is relational operators. Means for the comparison purpose we will take these relational operators. Equal, not equal, less than, greater than, less than or equal, greater than or equal. So we know about the relational operators. For the comparison purpose we will use. It also will come under the binary operator. For the comparison purpose, two operands or two variables required. Logical operators and or not. We know these operations we have seen in the previous classes. We know about the truth table. So in the truth table and or, it is or. two ampersands if we have, that is called logical and. Here these two pipelines, these are the pipelines. We have at the backslash button on the keyboard, we'll have this pipeline also. Two pipelines, it is called logical or. Here we have the exclamatory. It is called logical not, not purpose failure. Bitwise operators. Here bitwise and, bitwise or, exclusive or, negation, left shift, and right shift. Here bitwise operators will be used to uh, perform the operations on the bits. For example, if I am having 10 and 20, I am using 10 bitwise operator and 20 I am using. So that time 10 will be converted into a binary number, 20 will be converted into the binary number, means zeros and ones. That time for the two binary numbers, that will perform the AND operation. That will perform the AND operation. AND means it is like a product. Okay, or means it is like some addition. So here it is the bitwise operators. Negation means negative values will give us. Negation n is equal to minus n plus 1 is the result. Negation n is equal to, the result is minus n plus. For example, negation 10 is equal to minus 11 is the answer. So that is predefined. Internally, there is a meaning for that. Cap means exclusive or operation will perform. Left shift and right shift. So left shift means uh, multiplied by 2. Right shift means divide by 2. Here left shift means 10 left shift 1. If we have one time left shift, the time one time we will multiply by 2. So that is the answer. While doing the programming, I will show you. Special operators, comma, ampersand, size of. Size of is also a special operator. It gives the size of the data type. What's the size of the data type and all, we will see here. Next, we are having assignment operators. Assignment means we knows A is equal to 10. Equal is the assignment operator. For example, A plus is equal to 10. What's the meaning of that? A plus equal to 10 means A is equal to A plus 10. That is the meaning. That's the meaning. Here likewise remaining all other operators also. A ternary operator, 3 operands are required for this to perform the operation. Okay. We will see some operations after looking into the data types and all. So these are the list of operators you have to remember. Unary operators, binary operators, and ternary operators. Unary operators, increment or decrement operators. Binary operators, what are the binary operators? Arithmetic, relational, logical, bitwise, special, and assignment. Okay. Arithmetic, relational, logical, bitwise, special, and assignment. The ternary operator, this is the conditional operator, one operator we have. So it is about the list of operators in our C language. Now C language. Okay. Next concept, that is data types. Up to the operators, we covered the total C tokens. What are the C tokens we had? We had the identifiers, keywords, identifiers, constants, special symbols, then operators we have seen, which are all comes under the C tokens. With the help of them only, we are going to write the program. Now we have the data types concept. Sir, what is data type? Data types, why the data types are? What's the need of them? So here data types are required for the programming language because what's the need of the programming language to develop some applications. In the applications, we'll take some data and we'll process the data, we'll give the results, that is a meaningful information to the meaningful information as an output through the application. Means in the applications, what we are doing, we are processing the data, we are managing the data, we are storing the data, we are taking the data, we are processing the data, we are sending the results. Uh, that is also data which is having a meaningful information. So totally what we are doing, the managing of the data. So data can be the combination of many. Here, the data, if you take the mobile, we have the data. Text files are there. We have the image files, we have the video files, we have the system files, isn't it? So many files are there. So in order to manage them, we need some types. Here, while doing the programming in our C language, here mostly we'll process the data, that is the values, for example, integer values, calculations we are performing. Okay, those are all some numbers we are using. Numbers also should comes under some data types. And in the numbers also integral parts we are using, and fractional part if it is having, that is also one type of number, real number we are calling. Okay, we are having some characters, some A, B, C, or single characters if you want to use. So those will come under the character types. If you want some strings, hello, how are you, some that will come, that will be represented with double quotes, that's also a string type. So mostly these three kinds of data we are going to manage here, some integer characters and real values. Mostly here we'll manage. We are not going for images and audios and all. In the C graphics and all, and in the advanced programming, we'll have the managing of the images, some audio files and video files. That will be that is the separate concept. But here, minimum data, how we are going to maintain that integer values, that character values, string values, how to manage them. So we have to categorize the data. Based on that only we'll perform operations. So that's why data types are required to know the type of the data so that the processing could be easy. Okay. So here we have three kinds we are having: primitive data types or primary data types, user defined data types, and derived data types. We won't bother about all these. We'll see them later. First, let it be these user defined and derived data. Now here we are looking at the primary or primitive data types. Primary or primitive data types. Here primary or primitive data types, observe here, we have character, integer, float, and void. Okay, character data type. In the character data type, we are having signed character and unsigned character data type. Means here we'll use the signed means positive and negative values also we can use if we declare as signed character. Signed means the sign will be there, plus and minus. Those two values also we can declare here, we can process them. Here unsigned means only positive values will process here, only positive values. Here character means whatever we specify within the single quotes, that will be treated as a character. There is a special thing about the characters, that is the C language total alphabet will be maintained in the character only. Means whatever the symbols we are having, plus symbol, minus symbol, comma symbol, greater than symbol. So for all the symbols, all will be treated as an alphabet. We know about the language. If you take our English language, that is A, B, C, D, all will be treated as this. It is an alphabet A to Z. If you take Telugu, we are having the alphabet. Hindi, in every language there will be alphabet. Likewise, in our C language also we have the alphabet. The alphabet means the letters and symbols and the numbers, everything will be there all will comes under uh, the alphabet of the C. Okay, uh, and those will be represented in the character type, and each symbol will be having an integer number. A number will be given for the each symbol that we are going to see. And floating point data types. In the floating point data type, we have float double, long double. Float double and long double. These are the list of data types we are taking. In the integer, we are having int, long int, unsigned long int, long int, unsigned long int, short int, unsigned short int. For everyone, we have the unsigned, signed and unsigned. So if we are not mentioning anything and but taking only simple data type, it is nothing but signed data type. By default, the data type is a signed data type. Signed means positive and negative values also we can represent here. So this size here, this size also somewhat different. Unsigned long data type. Unsigned means only positive values we are going to represent. Okay, these are the list of data types. Void means nothing. There is no type for the variable which we are declaring. If we are declaring a variable without any type, we can use it for any purpose, means either for character type or for float or for integer, any another purpose we can use this void data type variable. So these are the list of data types: character, integer, float types we are having. So here character we have signed and integer. In the float we are having signed and integer means char only. Char by default, char, that is signed char. Here unsigned means unsigned space char. Likewise we will represent float, float double, long. In the integer data types we are having, these are the list of data. Okay, now let us see the sizes of the data types. Sizes of the data types. Actually, based on the our CPU or bit architecture, the sizes will be vary. Here, for character data type, the size is 1 byte. For character data type, size is 1 byte. Short 2 bytes, integer 4 bytes, long 4 bytes, long 8 bytes, uh, float 8 bytes, float 4 bytes, double 8 bytes, long double also will be having, that is 10 bytes. Long double also will be having, so that is 10 bytes. Here, what is this bytes, sir? Nothing is there. So whatever the letters we are specifying, that should be holded. That's why we need some storage, we need some size of that data. For example, if we are taking only single character, that character will be converted into a binary number. That binary number can be represented with 1 byte size space. Then only we will use the character data type. For example, integer 4 bytes. 4 bytes also, if you are taking some 10 is the number, that number will be converted into binary number. That binary number should be represented within these 4 bytes of memory blocks. Memory blocks low, if we are able to represent that 10 number, that is in 4 bytes of memory block, then we will go with int. If we are taking the long big numbers, more in the lakhs, for example 10 lakhs number, if you want to hold, it's good to go with some long int or long int. So big numbers also we can represent with these uh, data types. If you are taking small numbers, if it is 2 bytes, The numbers we can represent, that is minus 32,768 to 32,767. These numbers only we can represent, and that much data means the numbers we can represent, perform the calculations and all. If it is 4 bytes, we can represent this much 3, 3, 6, and 7. Nearly 200 crore number we can represent, positive and negative. 200 crore number we can represent. So if it is 8 bytes, this one, and if it is and long double also, there 10 bytes. Big numbers also we can represent with the help of these data types. Okay. So now let me show you an example with these data types. So till now we have seen all C tokens and data types also we have seen. So let us go with an example to know the size of the data type. For example, S dot C I'm taking C program. Hash include stdio dot h. Here into main. This is the syntax. If you want to know the size of integer data type, for example, printf within the double quotes, we can write the string size of integer or int. If you want to know the size of int, here that will be surely integer number that will display. For the integer data type, if we are using or if you are printing such kind of integer values, we have to use percentile d for the integer values. Okay, so let me complete that also. Percentage d as integer values, percentile f for floating point values. If you are using percentile ld, that is long integer purpose, we'll use this one. Percentage LLD for long integer purpose we'll use. These are the format specifiers. Next, percentage HD short int purpose we'll use. I think H only. H only we'll use. We need to check it once. Next, percentage capital LF will be for the long double. Will be for the long double. For double purpose also we'll use percentile F only. You have asked me, sir, what are these percentile D, percentile F, percentiles? What are these percentiles, sir? You have asked me. If it is an integer, we'll use percentile D. If it is a floating point value, percentage F. Long int, percentage LD. Long int, percentage LLD. Short int, HD. Long double, LF. For double also percentage F. If it is a character, percentage C. If it is a string, percentage S. So these are the symbols. You have to just remember the symbols. So now we are printing the size of the integer. So that time percentage D backslash N means escaping character. I'm going to print in the new line. So that's why I'm taking it, because control dollar prompt also will be appeared in the same line. That's why I'm taking backslash N here at the end. Here we have the operator called size of int. It is an operator. Observe here in the printf, the first part is the control string. Within the double quotes we'll mention. Within the double quotes, we will mention. Here, within the double quotes, whatever you are going to write, that is going to be printed. If you are using any formats specifiers like percentage %D, percentage %F, percentage %C, for them, we need to give the reference after the comma. After the comma, we need to give the reference. Actually, it is the operator which I have shown you. In the special operators, I have shown you size of int means it will give the size of the integer, how many bytes it is occupying. We can see it. Return 0. GCC space compilation, as I told you yesterday. GCC compiler we are using s.c, that will be compiled. So we have to run /a.out because compiled program executable file will be a.out only for every currently compiled. Here / is to run the executable file. Now you run it. What's the size of int? 4 bytes. Showing you 4 bytes. You can check it like that. If you want to know the size of float, size of float, size of float, you can check it. GCC space s.c /a.out. So here also it is giving 4 bytes only. This CPU it is taking for the float 4 bytes. If you want to know the size of double, we can check it. Compile 8 bytes. It is out. Yeah, the CPU is assigning 8 bytes. So we can check all the operators, how the operators are working. We can check here. If you want to read A values and perform addition, otherwise directly if you are taking some A and B values, some A is equal to 10, comma B is equal to 30. So this is the way of representing a variable. We can assign the values. Dynamic values means a fixed values also. Static values we are giving here. Dynamic values also we can take. Static means which are declaring and which are fixed. Dynamic means we can change at the time of runtime. We can give. So here directly I'm giving the values A and B values. I told you A is a variable, B is also variable. We can take variable name as based on the constraints which I have told you. Okay. Here directly I'm performing addition of two numbers. Addition of A and B. Here I'm taking addition of A and B. Some equal also I can give. And this is a string. That's why. Some colon also I can give. Here I am taking backslash and also and closing it after printing. Here the printing the result I am taking it in integer because here it is integer type A value and B value. The result also will be integer type. So that's why I am taking percentile D. I am taking percentile D. Here itself I am performing operation A plus B. A plus B. Observe here. So this string will be control string will be printed. It's my own string. Here I am writing. But for this percentile d, I'm giving the reference a plus b. It will perform addition of a and b. So that result will be given us. Okay, we can check it. GCC space s dot c dot slash a dot out addition of a and b, that is 40. We're getting 40. 10 plus 30, 40. If you want, you can take the floating point values also. You can take the floating point values. Float some variable x is equal to some 3.5. X is equal to some 3.5. So if you want to print the same floating point value, directly you can print within the printf statement. Float, if you want to perform addition of two variables, x comma y is equal to 4.2 and x is equal to 3.5. Then here I'm printing addition of x and y. So whatever the statement just you wanted to write here, you can write now, no problem. I'm writing in my own words. X and y is equal to percentile f. I'm taking percentile f, that is because it is a floating point variable. Backslash and I'm taking just to print in the new line, comma x plus y, x plus y. So the result will be in the floating point value. Means the fractional part also will be added. If you take it as percentile d, only the integral parts will be added, fractional part will be missed. So I am performing the addition of two floating point variables. So here, save it. GCC space s dot c, enter, dot slash a dot out. Addition of x and y, that is 7.70. 7.70. Here we can see 3.5 plus 4.7.7. So 6 precision points actually will be printed. Okay, by default after the point. Here, if you take the double variable, we can take double also, no problem. We can take double. So there is no much difference between these two. Some size difference. The format specifier is percentage f1. We have not tried character char data type. We are using char space. Some I'm taking some d is a variable. D is equal to, within the single quotes I'm mentioning some character, a special symbol or character, whatever you want, you can specify. Some G is a character I'm taking. Here D is a variable and G is a character. G is a character. How can we print it, sir? With the percentile C. With the percentile C, you can check value. Sorry. Value of D is equal to percentile C, because I'm printing a character value. Percentile C. For this percentile C, what's the reference variable? D. So we are printing D value. So that's what I'm giving here. Okay. Within the double quotes, this one after the comma. So for these percentiles, we have to give the reference. Okay, D value I'm printing here. Now you check it. GCC space s dot c dot slash a dot out. Value of D is equal to G. Is it printing or not? It is printing. So likewise, we can declare the variable, we can declare the data types and the values like this based on the type. We can access them with the format specifiers. Int percentile D for percentile F. For character data types, we will use percentile C. Mostly these three types we will use. Okay. So we have the many operators. So for tomorrow's, your task is just simply perform arithmetic operations. Okay. For today, it is enough. We can go with the programming or concepts on tomorrow. Instead of some control statements, likewise, we are going to see then how to read the values, how to access the values dynamically with the scanf. We can see in the tomorrow's class. Thank you.